Podcast where we want to investigate the concept of multiplicative inverse within modular arithmetic. In front of you, you can see that I just wrote what in non-modular arithmetic is an additive inverse, which is something that you already know, which is this particular number here, right, with a negative. So any number x with if we add the additive inverse, it should lead to the value of 0, right? We just subtract same magnitude with each other, then we get 0. Similarly, the multiplicative inverse of x is this number 1x, which when we multiply with x, then it should lead to the number 1. Now, what about question mark would be, what about modular arithmetic, correct? So what about these two, 1 and 2? What do they look like in modular arithmetic? So your textbook addresses additive inverse and multiplicative inverse. We're interested in multiplicative inverse for the moment. And what it says is if you have a mod n times some b mod n, this should lead, and then something like it's modular, and this is equal to, let's place it over here. It's just a times b module n. And with that, we'll check the inverse in a moment, because in this case, what about if this is our sort of like an x, and this would be our x minus 1, right? This is the inverse, but there is no fraction. This is just a way of saying is the multiplicative inverse. So what you get here, regardless of what you get, is if you have x times x minus 1 mod n, then this immediately turn out, I'm just going to write it over here, it turns out to be 1 mod n. It doesn't matter what numbers you have here, pretty much. So let's investigate that with Haskell for a moment. Let's jump into that right away. So here we can say, let's imagine that we're looking for an arithmetic. Oh, I think I can stretch this a little bit so you can see. Okay, perfect. This is what we're trying to figure out. So imagine that we search for the example in, let's take a look at the example from the textbook. It says that the multiplicative inverse of 3 mod 7 is 3 minus 1 mod 7, but this whole number should be, it represents something as a whole. So because this is what we're trying to find, to multiply against what is not the inverse of 3, but it's just 3. So let's figure out this, because we don't know what is this number. What we could say is find a number between 0 and 6, and that is given by the modulus number 7, such that it's equal to, so that the modulus of that number, such that any one of those numbers multiplied by 3 leads to modulus 1 of 7, right? It leads to 1 mod 7. So in essence, what we're saying is the following: create a list such that we want to multiply x 3 times x, such that x comes from a list of numbers between 0 and 6, such that the constraint would be the x is modulus one of these values. Actually, it will be here. But it's 7. Let's see. Oh, actually, it's 3 times x is modulus 7 will be equal And let me fix this. We want that particular x. Then it should be equal to 1. That is pretty much what we are trying to investigate here. So we hit enter here, then this list actually returns 5. If we follow a similar pattern with module the inverse of 2 mod 6, what's the number that multiplies 2 such that it's equivalent to or equal to 1 mod 1? And that is then a repeating solution of this other, except that this time we're using modulo 6, and we want a number that multiplied by 2 it's equal to 1. So in that case, oh, and I need to reduce the clock or the span of the set. So with that, we return an empty list because there's no such number. So here you can see that it says that 2 does not have a multiplicative inverse module 6, which is precisely what Haskell is telling us. Okay, so there is a way to, before start looking into this pair of numbers, whether there exists a number that is a multiplicative of 2. Imagine this is a list of very large number. You don't want to waste your time looking for that number if it doesn't exist. There's a method of doing to investigate that, and we're gonna take a look at it in the next screencast. Thank you for watching.